In this goal, you should be able to learn how to recognize examples of physical and chemical properties, and you should be able to differentiate between physical and chemical change. Also, we're going to talk about separating mixtures. Physical properties, these can be observed without changing the identity of the substance. So the name will stay the same, even though you might be changing the size or the shape. A chemical property, this refers to the ability to make or form new substances. As soon as you have demonstrated the chemical property, you have changed whatever that substance is. Here's some examples. Go ahead and stop the video and see if you can figure out if these are physical or chemical properties. Okay, melting point. If I go and melt an ice cube, it is still H2O. I just went from H2O as a solid to H2O as a liquid. So going from a solid to a liquid, that's just a phase change. It is still H2O. So this is just a physical change. Let's go to flammable. So if I can picture something that's flammable, if I show that it's flammable, like I burn a piece of paper, this would change the paper. So because of that, this is a chemical property. Density. If I show or calculate the density, I know it's mass divided by the volume. So if I find the mass, I find the volume, and then just divide those two numbers, I'm not changing what I have. So this is just a physical property. And then magnetic. If I take a magnet and stick it on my fridge, I have not changed the fridge or the magnet. So this is just a physical property. And I have tarnishes in the air. So if I can picture something tarnishing, so maybe I have like a silver spoon that my grandma has, and I know that it gets tarnished over the time. So there's actually a color change. It's a chemical reaction that occurs as that silver reacts with oxygen from the air. Now let's talk about physical and chemical changes. So signs of a physical change. There's a new shape or a new size or a new state of matter if I change it physically, but I can still call it the same name. Signs of a chemical change, these are always reactions. So I will have a new product that's formed. Now, when we use these terms, reactants and products, so these are chemistry terms. A reactant, this is the substance that I have at the beginning that's going to react together. A product, these are the new things that have formed. So a sign of a chemical change or reaction, I will have an unexpected change in color, or maybe there's a new smell that happens. Maybe a new gas is formed, or I have a solid that is formed if I put two things together, like two solutions together. Also, I can have a change in light or heat. Maybe it gets colder when I combine two solutions, or maybe it gets warmer when I combine two reactants. So these are the signs of a chemical change. And again, I'm always going to end up with something that is new with a chemical change. My physical change, again, it will have the same name. So go ahead and stop the video and see if you can figure out if these are physical or chemical changes. Okay, let's see how you did. So rusting iron. This is a chemical change. I get something new. I get something powdery on that metal. Dissolving in water. I can take salt or sugar and dissolve it into water, but then I can let that water evaporate or boil off, and I'll be left with the salt or the sugar again. So that is just a physical change. I can get the water and the sugar back. Burning a log. So if I imagine a log burning, at the end of it burning, can I go backwards? That might be another way to look at if these are physical or chemical. And no, I can't go backwards. So I have ash now. I don't have a log anymore. So that is a chemical change. Melting ice. If I melt it, can I freeze it again? And the answer is yes, you can. So this is a physical change. So I still have H2O. I still have solid water and then liquid water. And again, I can put it back to solid water. Grinding spices. Am I making anything new? And the answer is no. You still, the oregano that you have at the beginning, you can crush it up and you still have oregano. So I'm not making anything new. Physical changes, I alluded to this, they generally can be reversed. Chemical changes, you're making something new. And a lot of times it's not reversible, like with that burning of the log. We can use physical and chemical changes to separate mixtures. Remember, a mixture is just combined physically. And so I can use some physical processes to separate them out. So the first one is filtration. So if you ever have made macaroni and cheese, you boil the water, you add your noodles, and then you need to separate those noodles from the hot water. And so you can use a strainer. And this is a filtration. You pour your water and your noodles through the strainer or your filter, and you separate the solid from the liquid. And we could do the same thing in chemistry. So if I have some sort of solid that's in a beaker that's mixed with a liquid, I can use a piece of filter paper. So actually use filter instead of, so just like our noodles have little tiny holes that the water can go through, my paper right here, my filter paper, the water can go through, but the solid, the particles are too big, and so they won't be able to go through. So filtration is based on particle size. Another way to separate out a mixture is distillation. And so this is if you have a liquid mixture. So maybe I have two liquids right here. So this is a distillation setup. So I put my two liquids and I'm going to heat them, and I'm going to use a thermometer to control the temperature. And then I'm going to boil off, and those vapors will go up, and then I can force them through this condenser tube. Now, this condenser tube has a water jacket around it, and that will cool the gas. And so I can turn the gas that was boiling off, and I can turn it back into a liquid, and I can collect my liquid here at the end. So I'll be able to, at the end of this distillation procedure, have my two liquids separate. So one will still be back here at the beginning in that first vessel, and then the second liquid will be at the end. This is exactly how they make alcohol. They keep the temperature low, the alcohol will boil off first, they will condense it or cool it off, and then be able to collect it at the end. If you've ever gone by the freeway, you might have seen something that looks like this. So this is when they take crude oil and they separate into the different petroleum products. And they do it through this distillation process, through differences in boiling point. So here's what's inside the little tower. So it's a cooling tower. And so as they heat it and then as they cool it, they're able to separate off all these different fuels. So you can see gasoline's towards the top, and at the bottom is diesel oil. And that's because, again, all of these have different boiling points. Other ways to separate something physically would be magnetism. And there's a picture down here of a junkyard magnet. So they can separate out the metals from the other things that are not metallic. Fractional crystallization. So this is when you have different abilities to dissolve. Maybe you have a mixture of sand and sugar, and so you want to separate them. You could add water that would dissolve the sugar, but the sand wouldn't be dissolved. So then you could filter out the sand from the sugar water, and then you could collect that sugar water and then boil off the water and have the sand. So using the ability to dissolve, you could separate that sugar from the sand. Chromatography, we are going to do this later on in the year. It's using a difference in the polarity of the molecules to separate them out. And centrifuge, this is a way to separate out different densities. So you can see in the top corner here, we have a centrifuge that's separating out the cellular part of blood from the liquid part. So they put it into this drum, and the drum spins, and the heavier parts go to the bottom of the test tube, the lighter parts, the liquid part, stays at the top. And so they're able to separate out the different portions that are in the blood. Now, chemical separation, you have to use a chemical reaction to separate out mixtures. And a good example of this is what happens at Kennecott in our Kennecott copper mine. Actually, they get a lot of gold out of that mine too. So they take and they crush the rock, and then they put it into a big vat with water. And you might say, how are they going to get the gold? Because gold will just sink to the bottom because it's very, very dense. So what they do is they add a whole bunch of chemicals. They add some chemicals that will bind up the gold, and it makes the gold froth up or float. And so then they have all this gold froth at the top of these big vats, and they just skim off the gold from the top. Then they have to do another chemical process to get the gold away from the foam. And that's how they get gold out of that rock, all the crushed rock that they do. So with chemical separation, again, a lot of chemistry goes into it. So it's not just a simple process. You actually have to have a chemical reaction to isolate something, and then another chemical reaction at least to get that something by itself.